This example is going to help you in terms of how to use trigonometry when solving some force problems involving both inclined planes and straight motion. So one of the things you need to remember is the SOHCAHTOA rule. So that is SOHCAHTOA. And that tells you that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. What you need to forget at this point is that y is always sine thetas, and x is always cosine thetas. Just forget about that completely. That only works under special conditions, and you're really best off remembering SOHCAHTOA. So as the first example we're going to look at is a surface with no friction, and we're going to have a force that pushes down on a block. The block has a mass of m, and the force is going to be equal to 10 newtons. We're given that the angle here between the force vector and the horizontal is 30 degrees. The problem here is that we're going to try to find the normal force. And we're also going to try to find the acceleration. So as we know, force is a vector, and we need to break the force vector down into its components, and it's trigonometry that's going to help us do that. So one of the things that I usually do is I take it away from the actual problem and mark it as a separate triangle. So my separate triangle looks like this. And this is a right, you always have to have a right triangle. So this is a right angle. This is 10. This is 30 degrees. We can see that this side here, this vector, represents the force in the x direction, and this vector represents the force in the y direction. Now we're going to go back to SOHCAHTOA, and we're going to figure out what fx and what fy are equal to. So in this case, let's start with the sine. So the sine of 30 degrees is equal to, the formula tells us it's the opposite, which is going to be fy, divided by the hypotenuse, which is 10. We solve this for fy, and we get 10 sine 30. Oops, let's just fix that. 10 sine 30. We know sine 30 is a half, or you can plug it into your calculator. So we get the force in the y direction is equal to 5 newtons. Now we also have to find the force in the x direction. In this case, we're looking at a cosine. So the cosine of 30 degrees, and that we find from SOHCAHTOA, is the adjacent over the hypotenuse. And that's fx over 10. So that gives us fx equals 10 cosine 30. You either plug that into your calculator and you get 8.6 newtons. So note in the last example we were just looking at magnitudes. By looking at the picture, we can see that fy is not a positive value, but it's actually equal to a negative value. So fy is minus 5 newtons, whereas fx is still equal to positive 8.66 newtons. Now let's go back to the original problem that we had. So what we had was a block of mass m, and we had this force F going like that, and it was equal to 10 newtons. What we can do now is we can completely cross that force out. That is, get rid of it and replace it by its two components. So we can replace it by Fx is equal to 8.66 newtons, and Fy is equal to minus 5 newtons. Or we can just say it's equal to 5 newtons, but in that direction. Okay. So now we're in a position to find all the other forces that exist on this particular problem. So I'm going to do those in green. Okay, so we know that we have in green the force of gravity, that is the force exerted on the earth by the object by the earth, and we also have another force pointing upward, which we tend to call the normal force, Fn or N. I'm going to actually use N for this example. So now we look in both directions. So first let's look in the y direction. We're going to choose positive upward. Okay. In that case, we have N, which is positive, minus 5 newtons, which is negative, minus mg. And what we know about that is that this thing isn't leaping off or falling into the table, so we know that the acceleration is equal to 0. Okay. Let's just put in some value for the mass. Let's use m equals, let's say 2 kilograms. Then we have n minus 5, and we're going to use g equals 10, minus 20 equals 0. And that tells me that the normal force is 25 newtons. And note, if we didn't take into account the components, we wouldn't have gotten the right answer. The normal force is not equal to mg. mg is 20 newtons, which is not equal to the normal force. Again, try to remember that mg is not equal to the normal force in most situations. So now we found the normal force, and now we can look at the x motion. So I'm going to go to another slide. And so for the x motion, we had a mass m of 2 kilograms. We had an Fx equal to 8.66 newtons. From this, we know that Fx equals max, and therefore 8.66 equals 2 times the acceleration. The acceleration equals 4.33 meters per second squared.